Dear students, in this session we will discuss how to calculate the present value of an asset. Calculation of the present value of an asset is important in the context of discussion of the theories of investment. Now, as we have discussed in the previous class, in considering how to arrange a portfolio intelligently, a holder of asset must remember that different assets yield different returns and different maturity. Assets, different returns, different maturity. A wealth holder distributes his wealth, his portfolio, to purchase different assets with the different returns and different maturity. So when considering the desirability of different assets with the different returns and different maturity, the wealth holder must calculate present value of these assets. As commitment to an asset is made at present with the different returns and maturity, we have to compare the present value of an asset, which will give a stream of returns in the future. Then only a comparison can be made regarding the desirability of different assets. Now, the question is how to calculate the present value of an asset. Suppose that interest rate is 5%. Suppose that the market rate of interest is 5%. If you lend $100 today, after 1 year it becomes 100 plus 100 into 0.05 is equal to 100 into 1 plus 0.05 is equal to 105. So after 1 year it becomes 105 rupees. To generalize, if R is, so if the rate of interest is R, and if the sum lend today is P0, say 100 is P0, at the end of 1 year, P1 is equal to P0 into 1 plus R. P1 is equal to, that is 105 is equal to 100 into 1 plus 0.05. P1 is equal to. Then, if the P1 is again lent, P2 is equal to P1 into 1 plus R. P2 is equal to P1 into 1 plus R, or is equal to P0 into 1 plus R into 1 plus R. Since P1 is P0 into 1 plus R, so P2 is equal to P0 into 1 plus R square. P2 is equal to P0 into 1 plus R square. If an amount P0 is lent for T years, after T years, Pt is equal to P0 into 1 plus R raised to T. If an amount equal to 100 is lent at a rate of 5%, after say 10 years, it is P0 into 1 plus R raised to T. These are the future values. Now we consider the original question. If you are entitled to collect P1 from today, 1 year from today, 1 year after from today, after 1 year, what is the market value of that future claim? If you are entitled to collect P1 a year from now, after 1 year, what is the market value of that future claim? That is P1 today. For that, we solve this equation for P0. Now, from this, we will get P0 is equal to P1 by 1 plus R. P0 is equal to P1 plus P1 by 1 plus R. So, this is the present value of a claim to be received after 1 year. P0 is equal to, that is 100 is equal to 105 by 1 plus 0.05 from our calculation. Generalizing, P0 is equal to Pt by 1 plus R raised to T. P0 is equal to Pt by 1 plus R raised to T. So, in general, if you are entitled to a claim Pt after T years, its present value is P0 is Pt by 1 plus R raised to T. Actually, this is discounting, the opposite of compounding. This is compounding. The opposite, compounding will give you future values, discounting will give you present values. Now, a claim cannot be collected until far in future because it has very little present value. For example, if you have $1 million collected after 200 years, it has no value at all. After 200 years, present value of $1 million is very minimal. So this is how we calculate present value for a single amount. For a single amount, P0 is equal to Pt by 1 plus R raised to T. Now you consider a bond. You consider a bond. Instead of one claim collected at a future date, a bond represents series of claims collectible at different times in future. We will discuss the features of bond in detail later. For the time being, just imagine that a bond has a face value of say 1000, having a maturity of 5 years, with a coupon say equal to 10%. Coupon 10% means by the end of every year you can collect 100 and after 5 years you will get 1000 also. After 5 years you will get 1000 also. So in the case of a bond having a specific maturity, you are entitled to a claim at the end of every year. After 1 year 100, after 2 years 100, 3 years 100, 4 years 100, in the 5th year 100 plus the original sum 1000. Now suppose that a coupon is clipped and can be encashed having an amount R equal to say 100. R is equal to 100. Then the present value of the bond is equal to R by 1 plus I. I is, where I is the discount rate, plus R by 1 plus, so let it be R, 1 plus R square, 1 plus R square, plus etc. R by 1 plus R raised to n, plus P by 1 plus R raised to n. So, coupon having a face value equal to 1000, having n years of maturity. If it is 5, it is 5. Coupon rate is 10%. So, this is R by 1 plus 0.1, 1 plus 0.1 square, like that. Now, if we assume that the maturity date of the bond is far off in the future, that is an infinite maturity, a maturity of 30, 40, 50 years, etc., called a console or a perpetuity. A console or a perpetuity. A console is a bond with no maturity or a maturity after a long time period. Then this present value becomes PV is equal to R by R. R by R, present value. For example, if the console earn 50 per year, console earn 50 per year, and if the market rate of interest is R is 5%, 0.05, then the present value is 1000. Present value is 1000. And this gives us an important relationship between present value of the bond and market rate of interest. If R increases to 10%, it becomes 50 by 0.1 and it becomes 500. So there is an inverse relationship between the price of bond and interest rates. That is something which we will discuss in detail later in the context of demand for money. So, if you are entitled to a series of claims, then the present value is obtained by using this formula. And if the bond is a console, a perpetuity, PV become R by R. R by R. Let us see how it become R by R. Now, this formula can be written as R by 1 plus R into 1 plus R by, into 1 plus 1 by 1 plus R square plus 1 by 1 plus R cube plus etc. And this is, as you can see, is a geometric series with a common ratio 1 by 1 plus R, common ratio 1 by 1 plus R. So this reduces to R by 1 plus R into 1 by 1 minus 1 by 1 plus R. 1 plus R, and taking LCM here and solving, you will get it as R by R. So, remember this, if you are investing in assets with the different maturities and returns, to compare these assets, you have to calculate the present value of all the future claims. And this is by using the discounting formula, which is the opposite of compounding formula. If it is a single sum or if it is a series of sums, here it is obtained by the formula. In the case of a bond, you have a series of claims. So you have to calculate the present value of the series of claims to arrive at the present value of the bond. And the inverse relationship between the price of the bond, interest rate, etc. will be discussed in detail later. For the time being, this rate of interest R is the market rate of interest. That is it. This is how we calculate the present value of an asset. And calculation of present value of an asset is important in the context of investment theory, in the context of the theory of demand for money, etc. That we will discuss in detail later.